Hi, this is Steve Smith, and in this Pluralsight on-demand module, we're going to look at one of the fundamentals of software development, which is the interface segregation principle. The interface segregation principle represents the letter I in the SOLID acronym of Principles of Object-Oriented Design, and applying it can help you create projects and applications that have fewer hidden dependencies and are more cohesive and easier to maintain. In this module, we'll begin by defining the interface segregation principle and see why it's a problem when it isn't followed. We'll look at some examples of classes that have too many dependencies because the interface segregation principle was not followed, and these classes were forced to depend on fat interfaces. Once we've analyzed the example and found what the problems are, we'll refactor it in order to apply the interface segregation principle and result in a better, more maintainable design. Finally, we'll look at some tips for when and how to apply the ISP principle, and finally some related fundamentals and wrap up. So the interface segregation principle basically states that clients should not be forced to depend on methods that they do not use. This comes from the excellent book Agile Principles, Patterns, and Practices in C#. The corollary to this, of course, is that you should prefer small, cohesive interfaces to fat interfaces. I really like these motivational posters. You can actually put them up in your team room if you like, or in your cubicle. This one is the interface segregation principle, of course, and says, you want me to plug this in where? The idea here is that we have a very small dependency that we require, which is this upper left USB cable here, but instead of being able to simply plug that into a USB port on a computer, let's say, instead we're being forced to haul around this large dependency represented by whatever this widget here is that has knobs and switches and buttons as well as multiple USB ports, and is basically way more than we need. It does provide us with a USB port that we can plug into, but it also requires a whole lot more stuff that we don't actually care about. So when we talk about the interfaces that we're supposedly segregating with the interface segregation principle, it's important for us to further define what we mean by an interface. Of course, in C#, an interface is a reserved word and represents a non-implementable type that specifies a public set of methods and properties that must be implemented by anything that chooses to implement that interface. However, it's also the public interface of a class. So any class, any type, whatever its public interface is, whatever its public methods and properties are, if these are things that are used by some client and it only requires the use of some small subset of those things, it's possible that you would end up with a better design if you were to segregate that class in some way that made it so the client didn't need to use as much of it. An example of this would be the classic design pattern, the facade pattern, which basically lets you take a large class or a set of complex classes and replace them with a much simpler class that offers only the subset or interface that the client actually needs. Let's go ahead and look at an example showing how violating the interface segregation principle results in a worse design.